Welcome to Regular Achievers Educational. So for some months now, we've been looking at the AQA topic list you expected to cover in preparation for your GCSE exam, and we've covered for paper 1 and paper 2. So moving forward, we are going to be looking at some paper review, and we'll be starting from paper 1. So this past paper review is going to be split into two. So this is the very first part, and we're going to be having another part in the next episode. So please do well to stick to this platform and do well to subscribe and put on your notifications so that you'll be notified immediately we have a new video being uploaded. So this is an AQA exam board past paper for paper 1 for 2018. So please, it's very important when you have paper in these regards, you ensure you fill your information accurately. It's very, very key. You fill your information accurately before you proceed. Then secondly, you read the instruction. You see, one of the issues that some learners do have is that they just jump into the question and start answering it. And at the same time, you can see from this paper we have here, this is the foundation paper. When we are done with foundation paper, for paper 1, we also go to the higher paper for paper 1 as well before we move on to paper 2. And we're also going to repeat the same pattern for other exam board as well. So this is 2018, just like I mentioned the other time. And the time allowed is 1 hour, 45 minutes. Like I always advise my learner, please be time conscious when you're answering this relative paper. Okay, and you're allowed to use scientific calculator and physics equation sheet in this same regard. So let's quickly go into those questions. If you have been following quite very closely, you will realize that some of these questions you'll be seeing here were because we've taken them topic by topic and we have actually seen relative question in that regard. So figure 1 shows a cyclist riding along a flat road. Complete the sentence, choose answers from the box. So when we're doing a topic from paper 1 in energy, we've seen this kind of topic, this kind of question before. It says, as the cyclic accelerates, okay, the energy stored in the cyclist body decreases and the dash energy. Are we together now? So the very first one there is that as the cyclic accelerates, okay, the chemical energy stored in the cyclist body will decrease and the kinetic energy of the cyclist will increase. So these are the two answers you're expected to use from the box. Okay, now let's move on. They say the mass of the cyclist is 80 kilograms. The mass of the cyclist is 80 kilograms and the speed of the cyclist is 12 meters per second. We have to calculate the kinetic energy. You see, from the question already, you have your mass, 80 kilograms, okay? You have your speed, 12 meters per second. So all you need to do is to insert those values, okay? So your KE equals to 0.5 multiplied by 80 multiplied by 12 exponent of 2. Simple, 0.5 multiplied by 80 multiplied by 144. So if you multiply this together, that will give you 5,760 joules. Let's move on. It says, when the cyclist uses the brake, the bicycle slows down, and this causes the temperature of the brake pads to increase by 50 degrees Celsius. And the mass of the brake pad is 0.040 kilogram. The specific heat capacity of the material of the brake pad is 480 joules per kilogram degree Celsius. We have to calculate the change in thermal energy of the brake pad, and you have already been given the equation to use. That is the beauty of foundation. Even higher as well, they will give you the equation to use. So it's just for you to know how to apply it. So basically from here now, we can see our mass is given as is 0.040, okay? And we can see our specific heat capacity is given as 480, and our temperature change is giving us 50. So all you need to do, you just need to multiply everything together. Is 0.040 multiplied by 480 multiplied by 50, and you have your answer as 960 joules. It's as simple as that. Now let's move on. Let's move on. Let's move on. Say, how is the internal energy of the particles in the break pads affected by the increase in temperature? Okay, as the temperature increases, the internal energy of the particles of the break pad will also increase at the same time. Let's move on. All right, so we have the next question that says, Figure 2 shows how the current through a filament lamp changes after the lamp is switched on. You can see a typical diagram here giving us an idea of what we are talking about. Then I said that normal current through the filament is 1.5 amps. For how many seconds is the current through the filament lamp greater than 1.5 amps? How many seconds? So you just need to trace it down to the seconds. So you can see your 1.5 amps there. So if you trace it to where it meets it here, then you trace it down, okay, you'll be able to get the duration, and that is going to give you is 0.08 seconds. 0.08 seconds. All right, let's move on. All right, the next question there. The next question, they say, why might the filament inside the lamp melt when the lamp is first switched on? The reason could be that the current goes higher than the normal value. It might be that the current goes higher than the normal value. This could be the reason. Then the next one that says, the lamp is connected to a 24 voltage power supply and the current through the lamp is 1.5 amps. Calculate the power of the lamp. Power equals to potential difference times current. Your potential difference is given as 24 voltage and your current is given as 1.5 amps. So what you need to do, just multiply the two together. So that will be what? 1.5 multiplied by 24. Okay? And that will simply give you what? That will give you 36 watts. As simple as that. Good. All right, let's move on. Let's move on. We are making progress here. We are making progress. Okay. They say LED lamps are much more efficient than filament lamps. What does this statement mean when we say LED lamp, they are much more efficient than the filament lamp? This means that the LED lamps waste a smaller proportion. It wastes a smaller proportion of the input energy than the filament lamp. That is the meaning of that statement. Okay, so that means unlike the filament lamp, the LED lamp does not waste energy, does not consume much energy compared to that of filament lamp. You can just look at the case of your white bulb and those yellow bulb colored. That is what we're talking about in these regards. Okay, so the next question then, it states that, let's take a look at it. So you should draw a diagram, okay, to show 1.5 voltage cells should be connected together to give a potential difference of 4.5 voltage. Okay, so that means we have also have 4.5 voltage. That means we must have like 3 of this. Must have 3 of this. So, and already you know the symbol for your cells. This is one cells, okay? So connected to another, connected to another. This is what we are talking about. 1, 2, 3. This is a 4.5 volts. All right, so we have a typical sample here. So if you calculate the total resistance of the circuit in figure 3, the equation we have to use says resistance equals to potential difference over current. Since they've already given us in that regard, and we know our potential difference is 12 voltage, and the current here is what? 1.6 amps. How do I know? Because of the unit. It's quite very straightforward. So for you to find the resistance, so what do? You just divide 12 voltage by 1.6. That's 12 over 1.6, and that will give you 7.5 ohms as your resistance. Then the next question there states that the resistance of P is 3.5 ohms, okay? Then I say calculate the resistance of Q. If the resistance of P is 3.5 ohms, if the resistance of P is 3.5 ohms, to determine the resistance of Q, all you need to do is to subtract 7.5 from 3.5, and you determine the resistance of Q. And if you do 7.5, take away 3.5, that will give you 4 ohms. All right, let's move on. This is the students connect the two resistors in figure 3 in parallel. What happens to the total resistance of this circuit? What will happen is that it will decrease. If the student connect the two resistors in figure 3 in a parallel form, it's going to decrease. And why? It's because the current would be higher. The current will be higher for the same potential difference. Okay? Because the current would be higher. Would be higher for the same potential difference. I can just say for the same PD. For the same potential difference. It's as simple as that. It's as simple as that. All right. So this is a 4 marker. They say describe how the student could measure. It says student wanted to determine the density of a small piece of rock. Describe how the student could measure the volume of the piece of rock. This is actually very simple. So I will just do a bit of explanation. So the first thing is that for the student to determine the volume of the piece of rock, after filling what's it called, your cylinder with water, the first thing is to measure the initial volume. And after measuring the initial volume, let's say the initial volume is 28 centimeter cube. Okay, then you put the rock, and after putting the rock, you measure the volume again. Let's say that volume is now 38 centimeter cube. So for you to now determine the actual volume of the piece of rock, what do? You find the difference between the two. That is 38 minus 28, and that will give you 10 centimeter cube as the actual volume of the piece of the rock. That is how you have to go about that. Then we have the next question. Whenever you see something on volume, just prepare your mind that you are looking at questions on density. Let's say the volume of the piece of rock was 18 cm cube, and the student measured the mass of the piece of rock as 48.6 gram. We have to calculate the density of the rock in gram per cm cube. So if it's in gram per cm cube, it just means mass over volume, and that means you just need to do what? 48.6 over 18.0. And if you do that, that will give you 2.70 gram per cm cube as the density. Let's move on. Okay, we are progressing quite very well. Say figure 4 shows the density of different types of rock. Okay, what is the most likely type of rock that the student had? What is the most likely type of rock that the students had? How do we know that? Okay, from the measurement we got here, we are 2.70. So if you look at the type of rock we have here, which of them is around that range? You will see that it is limestone. Look at it. Limestone is the one around that 2.7. Others are beyond that 2.7 quite very well, and some are actually lower. So the one that the student likely have is going to be the limestone. You just look for the limestone, you take it, and there you go. They say give one source of error that may have occurred when the student measured the volume of the rock. That would be that, the eye position when using the measuring cylinder, because If the learner does not position the eye very well, or even while looking at it, the student can actually make a mistake. The eye position when using the measuring cylinder, that could be the error. Then I say, how would the error you describe in question 4 affect the measured volume of the rock? How could it affect? Because in that regards, it can make the volume to either be lower or higher. Because if you look at it wrongly, it can either influence it to make the volume of the rock to be lower, or it can make it to be higher. So let's go to the next one. We have americium 241, the mass, the atomic number 95 is an isotope of americium. They say which of the isotopes given in table 1 is not an isotope of americium, is not an isotope of americium. Now take a look at those isotopes we have there. Take a look at those isotopes we have there. Okay, you will see that the first one, the mass number is 243 and the atomic number is 95. And the second one, the isotope, we are seeing the mass number 243 and the atomic number 94. The third one, the mass number 242 and the atomic number is 95. And we know that isotope really means that those compounds that have the same what? They have the same, what is it called? Atomic number, but different mass number. They have the same atomic number, but different mass number. You can see that A and C have the same atomic number and different what? Mass number. But if you look at B, it has different atomic number, and that's what makes B not to be an isotope, okay, of americium, okay? And they say give your reason. Americium has an atomic number of 95, and that B has an atomic number of 94, and that makes it not to be an isotope of americium. Now look at the figure 5 shows how the number of americium 241 nuclei in a sample changes with time. You can see it right there. You have to first study the graph very well before you attempt the question. Then they now said that, let's take a look. How many years does it take for the number of americium nuclei to decrease from 10,000 to 5,000? From 10,000 to 5,000. So you have to first look at the 10,000 here. I'm coming. You have to look at the graph from 10,000 to 5,000. This is 5,000. You trace it, okay, to where it meets on the graph. Can trace it down. This will be around, let's say, 430. Okay, and for 10,000, that is 0. So if you do 430 minus 0, that means it's going to take 430 years. It's as simple as that. They say, what is the half-life of americium 241? What is the half-life for americium 241? It's very simple. The half-life is going to be that same 430, because it's just the same question that they ask us here. Because when we're talking about half-life, just the duration that you take for it to decrease. So the half-life, the duration that you take for it to decrease by half. That's what we call the half-life. So the half-life of americium 241 is going to also be 430 years. Let's move on. Let's move on. This is the last question we're going to be doing for now before we take a look at the next part of this paper in our next session. They say nuclear power can be used to generate electricity through nuclear fission. Okay, and we have a process of nuclear fission rightly described here. Now say complete the sentence. Complete the sentence. During the process of nuclear fission, a uranium what? A uranium nucleus. A uranium nucleus, okay, they will absorb a neutron, okay, and as a result of that, electronic radiation is released in the form of gamma rays. So your gamma rays, okay, you have your neutron, okay, and you have your nucleus. So those are the stuff you are going to use in that regard. They say the UK needs at least 25 million kilowatts of electric power at any time. A nuclear power has an electrical power output of 2,400,000 kilowatts. Calculate how many nuclear power stations are needed to provide 25 million kilowatts of electric power. So you just need to do 25 million kilowatts, okay, over 2.4 kilowatts. Okay, and you get your answer right there. That is going to give you coming 1, 2, 3, many 0. Okay, this is just now to this. Many 0 is here. 1, 2, 3, 1, 2. So these 3 crossed out. All right, this going to this. Okay, so this is going to give you 11. This is going to give you 11 nuclear power stations, and needed, we need 11 nuclear power stations to produce 25 million kilowatts of electrical power. All right, let's move on from there. So the next question says, we should state 2 environmental issues caused by generating electricity using nuclear power station. Number 1 is that, waste is radioactive. Waste itself is a radioactive. That's 1. Waste is radioactive. And secondly, we need to take note of the fact that waste is toxic, and they have a longer life. Waste, this is the second one. Waste is toxic, and they have long half-life. So that means they can disintegrate for a very long time. Then they say the UK generates a lot of electricity by burning natural gas. This process releases carbon dioxide into the atmospheres. Figure 7 shows how the concentration. It shows how the concentration of carbon dioxide in the atmosphere has changed over the past 115 years. Good. You can see it right there. Then the question says, okay, and they also give us another one, figure 8. It shows how the global temperature has changed over the past 115 years. You can see this one typically. They say give one similarity and one difference between the data in figure 7 and figure 8. So you need to calm down to clearly look at the trends. You need to calm down to clearly look at the trends. So if you study the 2 graph quite very well from figure 7, the way it looks, then you come to figure 8 and also take a look at it. There's one distinct similarities, and that is the carbon dioxide concentration. Okay, we can see that the carbon dioxide concentration, carbon dioxide concentration, and the global temperature have both increased within those period. Have both increased. That's the first one. And if you look at the difference, we can see that the carbon dioxide continues to increase, whereas the temperature levels off. That's the difference. We can see that the carbon dioxide continues to increase, whereas the global temperature levels off. So we're going to stop on this for today, and I do hope you've learned one thing or the other, even as you prepare for your GCSE exam. Do well to check this channel next session to see the concluding part of this paper, and please do well to keep studying. Do well to subscribe to this channel and follow, and ensure you put on your notification so that you'll be notified immediately we upload any relative video in this regard. Thank you and have a wonderful day ahead. Bye-bye.